We are discussing design questions, and design questions are now regularly coming. This is one question in every ATP. Design questions need some fundamental knowledge. A student states that the distance a toy car travels along a horizontal floor after rolling down a ramp depends on the mass of the truck. Plan an experiment to determine whether or not the student is correct. Student has an idea that if he rolls down, if he allows a toy truck to travels along the slope, it will when it is off the slope, it will travel some distance. So suppose I model a truck here for my explanation. This is a truck and it is coming down. When it comes down, it will travel on the straight road like this. It will travel and stop somewhere. So I will stop this one here. Then this is the distance. This is the distance which is traveled by the truck after coming down from the slope. Student thinks that the mass of the toy truck determine its horizontal distance. So read the question again. Design questions are a bit tricky. The following apparatus is available: a ramp, selection of masses, a toy truck, blocks to support the masses, any other apparatus or material usually available in a school physics laboratory like vernier caliper, micrometer, ruler, and thermometer, some standard apparatus which are available in the lab. I have given you a model here that the toy truck will slip down. It will slip down the ramp and it will travel some distance, and we used to play in our childhood, and that it will stop after covering some distance. The student wants to, this is the mass of the toy truck. The student wants to analyze mass versus D. A student wants to analyze the relation between mass and D. You're not required to do this experiment. List any additional apparatus needed. Explain briefly how you would do the experiment. State the key variables to control. Draw a table with column headings to show how you would display your readings. You're not required to enter any readings. You may add to the diagram in figure 1.1 to help your description. Now, please, I'm going slow because this is the first question for today. And design questions are not very difficult, but they are very unusual for people. So read this question again. So let's make some addition on the diagram. I put a mark here. Look, let me mark up. Let me make a marking here, a red mark. The purpose of this red mark is to, the purpose of the red mark is to keep the starting position constant. I will allow the truck, the toy truck, to go down, and it will reach the slope, and it will travel. And suppose it stops any position, say P. I will attach a meter rule like this. This is a meter rule. I will attach a meter rule like this, and my plan would be to measure the distance D. Measure the distance D. I will obviously use the ruler, and the ruler will tell me the distance. Now, how I can put the mass on the trailer, this toy truck? If the truck is in a shape of a carrier, I can put the mass inside it, or I can put the mass on the truck and tape it. Look, this is the mass, and put a tape on it. So I can put the mass on the toy truck, and this is the mass. So I have upgraded the experiment diagram. Now the procedure will be very simple. I will release the toy truck from the mark, allow it to go down, and I will measure the distance. First, I will let the toy truck go without any mass. Then I will put some mass. The laboratory masses are marked: 5 gram, 10 gram, 20 gram. Laboratory masses are with marking, so I know how much mass I'm adding. So I will put the mass like this. I will put the mass on the toy truck and allow the truck to go down. When it goes on the floor, it goes forward and get the distance D. Now, I will keep on increasing the mass, and I will keep on recording the distance. Then I will record the values in a table, and I will see that I draw a graph of mass versus D. Mass versus D. Examiner says that what about the variables? The variables means two variables. Our present question is about mass and distance. I am changing the mass, so it is I am changing the mass. So it is my independent variable, and the distance is this is my dependent variable. And because we have to change the distance, we have to change the mass. Something which you are changing yourself is called the independent variable, and something which is changing according to it is the dependent variable. Actually, I should keep the height constant, because if I change the height, it will change the distance on the ground. Let me call it h. Now, I have explained the whole experiment, and I will explain it once more. Let me check the mic position. I have explained it once, and I want to explain it again, because so then you people can tell me what should I do. Now, the procedure is there. I will allow the toy truck to slip down the track and see how much it goes forward. Then I will put some mass on the toy truck. It will go down with the mass and it will stop at a position. Then I will keep on increasing mass, and I will be checking for the distance in every time. I will be checking the distance traveled by the truck every time. Then I will record the values of mass and distance. Height I'm keeping constant. I'm preparing for a table. Examiner says you have to mark, examiner says you have to mark the table, but you're not supposed to enter any values. So one column, as I'm changing the mass, so now copy this whole everything. You should have either you should have a printout of this document, or you should try to write on your device, so you can share with me also what work you are doing. Copy the whole, update the whole screen, and you can, I think you can answer me on the mic also. I have explained the experiment. This is called design question. You can ask your questions by now, then we can proceed. This is the diagram. Copy the diagram. Let me know once you have copied it. This is the second question, and a student is investigating the force needed to slide a wooden block across a surface. He notices that some blocks need more force to start to slide with, and some other blocks do. He suggests that the amount of force needed depends on the mass of the block. So this is the question, and he has given us some initial information. This is the simple diagram I have made. Copy the diagram and let me know once you have copied it.
What is written next to the block?
Now, how we can increase the mass of the block? We can put some masses on the block also. If we put some masses, or we can double the blocks, we can put another block on it. We have to increase the mass of the block and the force. Actually, you have to alter the mass and the force. You have to measure. The amount of force needed depends upon the mass of the block. So you basically want to compare mass versus force. Now, what you are varying, actually, you have to vary the mass of the block. You have to vary the mass of the block, and you have to determine the force which slide the block. Now, what is the plan? You will start adding the mass in the pulley, the mass hanging, the hanger. You have to start adding the mass in the pulley. And as soon as the block begins to move, you have to stop. You have to note down the mass which is creating the movement in the block. You will continue this. You will continue this for different masses of the block. And then you have to record the values of force and the mass. I repeat the plan. I repeat the plan that I have to find the force at which the block begins to slide. It's a hanger, mass is hanging. So I will start adding the mass in the hanger. I will start adding the mass in the hanger. Now, as soon as the block begins to move, I will note down the mass, and that will be the reading for me. Let me update this diagram, and let me make a hanger here. This is a hanger. So I will start adding the mass there. I will start adding the mass, and it will go down. Then I will increase the mass of the block. I will increase the mass of the block. Keep on adding the masses, and the block will begin to move. Then I will I will put some mass on the block, make it heavy, repeat the trial, and for different masses of the block, I have to determine the force. Now, this is the procedure. Mass of the block, we will change. This is the independent variable. Force dependent variable. Now, how we'll make the table? We will make a table here for our discussion. Now, look at the table, and you should copy this with me. And this is the serial number 1, 2, 3, 4. And I have mass of block in gram, and the force in Newton. Now the plan is there. You will take the block, you will arrange it like this. You will start putting the masses in the hanger until the block begins to move. Then you stop the trial and you will take the same block, but put some masses on the block also. So the mass of the block will increase. Again, you will start loading the hanger until the block begins to move. In this way, you will repeat the trial. How we get the force from the mass? Remember that mass can be converted into weight. Mass can be converted into weight by the formula W is equal to mg. Now, what would be the procedure? We will tell examiner that we will arrange the apparatus as shown. This is our apparatus. We will arrange the apparatus as shown. This is the procedure. Give the heading procedure. Arrange the apparatus as shown. Start loading the hanger with known masses. Start loading the hanger with known masses. Start loading the hanger with known masses until the block begins to move. Until the block begins to move. Note down. Note down. Note down the total weight added. Note down the total weight added. Note down the total weight added. Now put some mass on the block. 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 Repeat the trial. Repeat the trial for different masses of the block. Repeat the trial for different masses of the block. And record the values in a table. And record the values in a table. Now copy this graph, copy this template graph. You're not supposed to draw the graph in this topic. You just have to show the axes. He says, describe any precautions the student should take to ensure repeatable results. So what precaution you think the student should take? We have done other parts of the targets. We have done the list operators, anything we have mentioned. Now, what are the possible precautions the student should take to ensure repeatable results. The student should start the block position every time from the same, like put a marker on the table and every time move the block from the same position. Secondly, as the block suddenly begins to move, student can record the experiment by a video camera to precisely see at what position block begins to move. These are some precautions, and this type of precautions are general precautions in a laboratory. So let me please inform me if you people have copied the whole screen. Let me know if you people have copied the whole screen.
Yes.
Okay, Hamad, have you copied it?
Yes.
Okay, so we stop here. This is our first class on design question, and we will put some more classes because this is a difficult topic, inshallah, in the next class now. Thank you. Allah Hafiz.